My dear students of Btech second year, I am Dr. Ravin Parsai, Associate Professor of Mathematics in Engineering Science and Humanity Department at Chamradevi Group of Institution. I wish to teach you through lecture 5. Factorial function, other difference operators along with the relation between them here. So first of all, we understand what do you mean by factorial notation or factorial function. So a product of the form x into x minus 1, x minus 2 up to x minus r plus 1 is denoted by x of r and is called a factorial notation or factorial function. So in particular, for first order, the value of factorial function is x. For second order, you are having two factor. One factor is x into x minus 1. Similarly, you can continue for third order case. You are having three factors and so on. You are having for nth order, you are having n factors having this value here. So if the interval of difference is h, then we can say to define this factorial function as x into x minus h, x minus 2 of h, and so on n minus 1 of h. So the factorial notation is of especially utility in the theory of finite differences. It helps in finding the successive differences of a polynomial directly by simple rule of differentiation. That is, if you want to find the forward difference of a difference of the factorial function, then you can find as r into x to the power r minus 1. So to express a polynomial of nth degree in the factorial notation, we use the following two steps. Arrange the coefficient of the powers of x in descending orders and replacing the missing powers by 0. Using the detached coefficient, divide by x into x minus 1, x minus 2 up to x minus n minus 1 successfully. So let me understand this method by an example. Suppose a question is express a polynomial 2 into x cube minus 3x square plus 3x minus 10 in a factorial notation and hence find all differences. So our duty to assume the factorial function of the given function is in the ways. So x into x to the power cube. So then plus b into, by taking another coefficient arbitrary, b into x to the power 2, c into x to the power 1 into d. Now our objective is to calculate ABCD by using synthetic division method. Is the most simplest method, in which here is the number of steps in the first step. So first of all, you write down the coefficient of x cube, x2, x and the constant. So 2 into 2 minus 3, 3 minus 10. So the constant term is always matched with this, equal to d equal to minus 10. And then we come to the second step. So first step is as it is, the remainder is as it is. Now for finding the remainder of this, just multiply the previous remainder by the number of steps. So 1 into 2 is 2, and then add on this. So minus 3 plus 2 is minus 1, you will get balance, and then this remainder is multiplied by number of steps, that is 1 into minus 1 is minus 1. So this gives to you 3 minus 1 is 2 equal to c, and then you can continue for the next step. Here you write as third step के लिए first we write as it is, then multiply this remainder by the number of steps, 2 to the 4. So minus 1 plus 4 is balance is 3. So this is the value of next coefficient is b, and now we come to the third step as we write the total here. So this is the value of a. Hence from the above synthetic division, we have the obtain the factorial function of the given polynomial as 2 into x cube plus 3 into x square plus of x minus 10. Now from the above concept we can find their differences. सो फर्स्ट डिफरेंस निकालने के लिए 3 टू जा x हो जाएगा. सो 6 into x2 plus 6 into 1 and then plus 2. Since delta of x raised to r is equal to r into x की power r minus 1, by using this formula we can simplify this. Now for obtaining the second difference, again you apply this 6 into 2 12 into x की power 1, then 6 into 1 की power 0. जीरो ऑर्डर का फैक्टोरियल फंक्शन की वैल्यू होती है 1 एंड द कांस्टेंट का डिफरेंस क्या होता है 0 होता है. तो 2 minus 2 करेंगे तो 0 मिलेगा. सो ओनली द वैल्यू इज प्लस 6. सो 12 into x plus 6. Now one more difference is remains here. Delta cube of f of x equal to 12 into 1 is 12 and then 0 power 0, the factorial function of 0 order is 1 and plus 6 is 6 minus 6 is 0. So we constant term having difference is 0. So let me consider the other difference operators which are to be useful whenever you have to find higher order forward difference or backward difference values. You can apply this shifting operator. These are the difference operator. First operator is shifting operator, is operation of increasing the argument x by common differences so that e of fx equal to f of x plus h. So this is the first, and then you can obtain the, when you repeat this process second times, so one more h is adding, so this gives you x plus 2h. In general, nth order shifting operator is e raised to n of fx equal to x plus nh. So the inverse operator e raised to minus 1 is defined by, you take माइनस पावर ऑफ दिस, n की जगह माइनस 1 रख देंगे तो यह आ जाएगा आपका x माइनस एच. सिमिलरली e की पावर माइनस n के लिए हम लोग इन जनरल बात कर सकते हैं f of x minus nh. So now we consider the next operator, difference operator is averaging operators. So averaging operator mu is defined by the equation mu of f of x equal to 1 by 2 of f of x plus h by 2 plus f of x minus h by 2. Now we consider another difference operator which we called as central difference operators. So delta of f of x equal to f of x plus h by 2 minus f of x minus h by 2. So in the difference calculus, delta and e are regarded as the fundamental operators, and delta and mu can be expressed in terms of this. So let me see the following useful relation between them. So forward difference equal to e minus 1, that is shifting operator minus 1, while the backward difference value is 1 minus e raised to minus 1. For the averaging operator value is e raised to 1 by 2 minus e k power minus 1 by 2, and for this averaging of as averaging operator, this is central difference operator is 1 by 2 of e raised to 1 by 2 plus e k power minus 1 by 2. So, and we can obtain the relation between them. So forward difference equal to lambda e into lambda, as the backward difference or lambda into e equal to delta into e की power minus 2, and the shifting operator equal to e raised to exponential raised to h into d, where d is the difference operators as differentiation law. Let me come to the estimate the missing term in the given tables here. Suppose this is our given table having the corresponding values of x and y. Whatever missing you assume as y is given to you. Here two values are missing. Okay, let us prepare. We'll assume these unknown values by p and q. Let p and q be the missing values in the given table. Then the difference table is as follows. Now we prepare the difference table. We know that how can we prepare difference table? First by writing the value of independent variable as arguments, and then by writing the value of dependent variables. So 3p, 2q and minus 2.4. Now as we prepare the difference table, just like that, subtract from this to this p minus 3 then 2 minus p, then q minus 2, then pi minus 2.4 minus q, then you will continue again calculate these values. So by taking the difference of this, 2 minus p plus 3 is 5 minus 2p, q minus uh, q minus 2 of minus 2 of plus p, that is p plus q of minus 4, then difference of this minus this gives you my 0 minus 0.4 minus 2q. Again you find the difference. You can continue one more difference by taking the difference of this. Because we are having two unknowns, we require two algebraic equation in p and q. That's why we equate to 0 the second last difference from these tables. Since there are two missing terms in the tables, so the function y can be expressed by second degree polynomials. Therefore, on putting delta q bar by 4 of 0 equal to 0 and delta q bar by 1 equal to 0, that is from the table 3p plus q minus 9 equal to 0 is the value of this difference, and delta q by 1 is the value is 3.6 minus p minus 3q equal to 0. Now you solve algebraically these two equations for p and q. We get p equal to 2.925 and q equal to 0.225. Now we solve the above problems by an alternate methods. Determine the missing values in the following table without using difference tables. So this is our question. Given that y0 equal to 3, y2 equal to 2 and y4 equal to minus 2.4, and missing values by taking as y1 is equal to p, y3 equal to q. Since three entries are given in the function, y can be represented by second degree polynomials. So therefore delta q bar by 0 equal to 0, delta q bar by 1 equal to 0. On putting these two difference to be 0. So how can you find the third difference? By using shifting operators. So e minus 1 whole cube bar by 0 equal to 0, e minus 1 of whole cube bar by 1 equal to 0. Because we know the relation between shifting operator and forward difference operators. Just by opening this bracket by using the formula algebraically, a minus b whole cube, and then operate y0 inside. So a cube minus 3a square b plus 3ab minus 1 of y0 equal to this. Similarly here you are applying the same algebraic formulas. Now ऑपरेट दिस इनसाइड e की पावर 3 है तो इसके सफिक्स में 3 जुड़ा होगा तो ये y3 हो जाएगा. e की पावर 2 है तो इसके सफिक्स में 2 जुड़ेगा तो ये हो जाएगा 0 प्लस 2 इज y2. इसके सफिक्स में 1 जुड़ेगा तो y1 हो जाएगा, ये माइनस y0 हो जाएगा इक्वल टू 0. सिमिलरली यू कैन प्रोसीड दिस टू दिस. हियर e की पावर 3 y1 है तो यहाँ पर y4 हो जाएगा माइनस 3 ऑफ y1 y3 plus 3y2 minus y1 equal to 0. Since e की power n equal to, we know that the method of shifting operators for nth order for yk is y of n plus k using this formulas. Now just substituting from above all these values, you will get two algebraic equations in p and q. That is 3p plus q minus 9 equal to 0, 3.6 minus 6 minus 3q equal to 0. Again on solving these equations we get p equal to this 2.092 and q equal to 0.25. Thank you very much.